This is the second session on a series of object-oriented programming. In this session, we are going to look at the coding aspects of object-oriented basics. We can look at object-oriented programming in three levels: the basic concepts, the core concepts, and the advanced concepts. We are in the basic concepts. When it comes to object-oriented software development, we look at a system as a set of objects that communicate and collaborate by passing messages in order to achieve their objectives. An object can communicate or send a message if they are associated objects. The very basics of object-oriented programming is the concept called object. Object is anything that we are interested related to the system. In some cases, we call them entities as well. In order to understand better, we can classify objects into three categories: the living physical objects like customer or employee, the non-living physical objects like goods or vehicle, and also the conceptual objects. For example, we can consider an account, an order or payment. So when it comes to objects, we are interested in two things. Those are the attributes and behaviors. So attributes are either properties of the object that we are interested. For example, if it is a bank account, we are interested in the account number, the balance, and also it can be a state of an object. For example, if you take an order object, so we are interested in the state of the order. It can be in the new state, it can be in the paid state, or later it can be in the dispatch state. So the second aspects we are interested about objects are its behaviors. The behaviors are the functionalities that the object can contribute to the system. So sometimes we call them services as well. So let's take a bank account object as example. So what are the interested attributes and behaviors? So we are interested about the account number, the balance, the interest rate of the account, and also the services that the account object can provide are the deposit behavior, the withdraw behavior, add interest, and some other behaviors that we are interested. So when it comes to a system, there can be thousands of objects. So we can't model each and every object. So therefore, we have a concept called class. A class represents or models set of similar objects. And later we can use class as a blueprint or factory to create objects. So in order to represent all the customer objects, we can model a customer class. To represent all the car objects, we can model a car class. And similarly, to represent all the bank account objects, we can model an account class. And once we model a class, we can use that class as a factory or blueprint in order to create objects at the runtime. Because when it comes to practical scenarios, it is objects that do certain tasks. When it comes to coding level, we are interested in three different aspects: the variables, the methods, and constructors. The variables represents the data and they need memory allocation. The methods represent the processing logic. The constructors are like methods, but constructor can be called only at the object creation time. All our attributes will be mapped into variables and the behaviors will be mapped into methods. The constructors are the separate concept, though they are somewhat similar to methods. All our attributes must be mapped into either instance variable or class variable. So what is an instance variable? If every object gets its own value for a variable, we call it an instance variable. For example, if you take a bank account object, its account number, its balance, so these values are specific to each and every object. Therefore, those are candidates for instance variables. And when it comes to memory allocation, each object will get its own copy of instance variable. And these instance variables can be accessed only through object references because these values are specific to a particular object. So then we have the class variables. The class variables are the common variables for a class, or all the objects of that particular class are referring to that particular value, a single value. Therefore, the memory is allocated only once per class variable because all the objects are referring to the same value. So these class variables can be accessed through the class name, or else you can refer them through your object references as well. But in most of the cases, the form approach that is using the class name is preferred. So then we have the instance methods and class methods. If a particular behavior refers to any of the instance variable, we consider it as an instance method. The instance methods can access class variables as well. Since they are referring to an instance variable, when you call an instance method for a different objects, the outcome can be different. For example, you go to the ATM machine and withdraw, and you may get the money. At the same time, when I try to withdraw, I may not get the money. Maybe my balance is not sufficient, whereas your balance is sufficient. So therefore, we call them instance methods because the logic depends on the values of instance variables. So we can call instance methods only through object references. So the other type is the class methods. So the class methods contains the generic logic. So the class methods cannot refer to any of the instance variables, but they may refer to class variables. So these class methods can be accessed by your class name, and again you have the facility to access class methods through your object references as well. The fifth element in a class is the constructor. So the constructor is pretty much like an instance method. The only difference is the constructor is automatically called when object is created. So you can't call constructor at any other time. And the constructor also has access to the instance variables and class variables. And this is the big picture of the instance variables, class variables, instance methods, and class methods. We can clearly see that every object gets its own instance variable values. And since your instance method refer to the instance variables, we have to consider it very close to the objects. The constructors can also refer to the instance variables, which are specific to a particular object. But when it comes to class variables, those are common variables. And also the class methods can access those class variables. So this is the overall structure of our class and its implementation. So when it comes to UML language or the modeling language, we model a class using rectangular shape. So we have the class name, its attributes and behaviors. And this is the coding representation of the account class in Java language. So the account number and balance we have mapped to instance variables because they are specific to individual objects. The interest rate is a common value, so therefore we have modeled it as a class variable. So then we have the constructor, and the deposit, withdraw and add interest we have modeled as instance methods. The reason is those behaviors are going to change or refer to the balance. Balance is an instance variable. So therefore we have to consider them as instance methods. And we have two more class methods, the set interest rate and get interest rate. They are not referring to any of the instance variables. This is the final code of the account class. So we have two instance variables and a class variable. In Java language, class variables are marked using the static keyword. So then we have the constructor. So in Java language, the constructor is given the same name as your class name, the case sensitive class name. And also it must not return anything, not even void. So then we have set of couple of instance methods, the deposit method, the withdraw method, and add interest method. And you can clearly see that these methods are referring to the balance, which is an instance variable. So therefore, we have to consider them as instance methods. So then we have the two class methods. Again, you can see we have marked with static keyword, and those two methods are not referring to any of the instance variables. So therefore, we can mark them as static or class methods. Now let's see what happens when an object is created. So this is how we create an object in Java language. So the object creation has three steps. In the first step, we are creating a reference variable to an object. In this case, our A1 is a reference variable to a count object. So these are something similar to the normal variables. Say when you declare something like int x, x can keep an integer value. Similarly, this A1 can refer to a count object. So the second part is the creation of the object. So when object is created, the memory is allocated for instance variables. And if this is the first object of that particular type, the memory is allocated for class variables as well. But that happens only in the first, when you are creating the first object. In subsequent object creation, the class variables are already initialized. So the third part of this statement is assigning the reference variable to the object. Now these reference variables and objects are independent. So you can consider this reference variable something like a remote control. So your remote control can control or access a particular object. So this is where you assign that this reference variable is referring to the object that you newly created. But these are independent concepts. Therefore, this reference variable may later refer into a different object as well. And also, a particular object may be referred by more than one reference variables as well. Now let's see what happens if we create another object of a count. Again, we have created a reference variable, a separate remote control. Now we are creating the second object. Separate memory is allocated for instance variables. And now we are assigning the second reference variable to the object. So though we have mentioned instance methods, here actually there are no separate memory allocation. Since these methods referring to the specific instance variable we have represented here, though they are common logic. Similar applied for the class methods as well. So the class method is again a common logic, but anyway, you have only one copy of class variable. Since these reference variables and objects are independent, we can freely change the reference variable from one object to another object. For example, if you have a statement like A2 equal A1, now what does it mean? Now A1 is referring to the first object, A2 is referring to the second object. So A2 equal A1 means we ask A2 reference variable to refer to the object that A1 is currently referring. Obviously A1 is referring to the first object. So therefore, after this statement is executed, A2 reference variable is also referring to the same object. So it's something like this. And now none of the reference variables are accessing or referring to this particular object. So in programming, we say that this object is now garbage collected or candidate for a garbage collection. Now let's see how these components can interact with each other. So let's start with constructor. The constructor is called when an object is created. Your constructor has access to the instance variables, and also your constructor can call other instance methods. The constructor can call the class methods as well. And the class methods have access to the class variables. The class methods can call other class methods as well. And also your constructors can directly access the class variables as well. So those are the interactions your constructors are capable of doing. Now let's move on to the instance methods. Again, the instance methods have access to the instance variables. So that is why we call them instance methods. And also your instance methods can call other instance methods. At the same time, your instance methods can call class methods. And of course, we know that the class methods can call other class methods, and also class methods can call class variables. And also the instance methods have access to the class variables directly. Now let's see how can we access these objects and the class related things from outside. We can call our instance methods through our object references. For example, using A1 object reference, we can call the instance method of A1, the first object. Whereas through the A2 object reference, we can call the instance methods of the second object. Again, when we say instance method of second object, we are just calling the same logic. Because they are referring to the instance variable only, we have marked it in the inside the object. They are the same logic. Since the logic may depends on the instance variables, for example, in this instance method, it may go to the if condition, whereas in this instance method, it may go to the else part, depending on the value. Other than that, the instance methods are the same, unlike instance variables, where you have separate values. And of course, once you call the instance methods have access to instance variables, and also instance methods have access to class methods. And class methods have access to the class variables. So that is how we work with instance methods. So that is how we are supposed to work with objects. That is what is meant by passing message or calling a service. There are some alternative approaches as well. For example, your reference variables can access your instance variables directly. But that is not the preferred way because it violates the concept called data hiding. We will be discussing those aspects later when we are discussing the object-oriented concepts. So when it comes to accessing class methods, the preferred approach is use your class name to access your class method. If you are calling from outside, of course, from inside your instance methods can call your class methods, but from outside, the preferred way is use your class name to call your class methods. And of course, your class methods have access to the class variables. So if you want, we can directly access class variables from the class name as well, but again, it violates the concept called data hiding. So therefore, usually we don't recommend doing that unless you have a special reason to do that. And there's another way you can access your class methods and variables. That is, rather than through your class name, you can access those through your object references as well. Again, we have to do this only when it is absolutely necessary. There are situations we have to do this. We have to do that only when it is required. So let's wrap up those concepts in little bit more details now. Constructor is an element in the class which is automatically called when object is created. You can use your constructor to initialize your instance variables or initialize any other resources like file handling, database connectors, etc. And your constructors can be overloaded, which we will be discussing later. And your constructors have access to the instance variables and class variables. Your constructor can call any of the instance methods and also it can call any of the class methods. So when it comes to instance variables, you can access instance variables by your constructor or instance methods. Your reference variables can access your instance variables directly, but that is not the preferred approach. The preferred approach is your reference variables called the behaviors and behaviors accessing the instance variables. Now let's look at the class variables. So the class variables are variables where we have only one value per class and every object can refer to the same value. So from internally, your constructors and instance methods have access to the class variables, and also your class methods have access to the class variables. From outside, the preferred way of calling the class variables is through your class name. And again, it's better to call the class method and let method access the class variable. And the other approach is you can use your object references to access your class variables directly or through class methods. Again, you must know the pros and cons of direct access of variables versus indirect access through the class methods. So this is how you access a class variable through an object reference. This is how you access a class variable through your class name. So this is preferred. But it is even better if you can access the class methods and let the class method access it. So we will be discussing those things in detail when we are doing the coding session. That will be our next session. So now let's move on to the instance methods. So again, you can call instance methods by your object references. And your instance methods have access to the instance variables and class variables. And also your instance methods can call other instance methods and class methods. Finally, we have the class methods. So your class methods have access to the class variables. So they don't have access to the instance variables, so they can't call instance methods or constructor or anything like that. Again, the preferred way of calling the class methods is by the class name. The alternative approach is you can call your class methods by object references. So these are few points that you can think about. So the first point is, why aren't class methods allowed to call instance methods? You can see that instance methods can call class methods, but not class methods can call instance methods. What is the reason? So think about it. The second point you can think about it, why is it the best practice to access variables only through methods? So here you can see that the best practice of accessing your class variable is through the class method. The best practice of accessing your instance variables are through instance methods or constructor. So direct access is allowed but not preferred. So think about the possible reasons. In summary, in this session we discuss how to code your class and then how to create objects from your class. What is object reference and what is constructor, and the difference between instance variables and class variables, the difference between instance methods and class methods, and how these elements can interact with each other internally and how can we interact with those from outside using object references, class names, etc. Still we are in the object-oriented basics. Today we discussed the coding aspects, but we didn't do any coding session. So our next session will be doing some practical hands-on coding and how to test whether these things are happening properly. So then we can move on to the object-oriented concepts and advanced concepts. If you feel like this session is interesting and useful, make sure you like it, and also make sure you subscribe so that you will be notified when new sessions are uploaded. Thank you.